going to talk about section 4 in chapter 14 on integrated rate laws. So first, of course, we're going to start talking about the concepts behind integrated rate laws. Then we're going to move into working with Excel. You're going to want to do this on your computer, of course, so make sure you have that out. In this chapter, we learn multiple methods for determining the rates of reactions by analyzing concentrations at various time points, as well as by just measuring initial rates. The method we're going to use today is to use calculus to actually decide what the concentration should be at a specific time point, given initial rate and or information about the concentration at a specific time. The first rate law that we are going to describe is the first order rate law. For a first order process, we can derive that the natural log of the concentration at time point t, that's what A sub t means, so this is a concentration at a specific time point, divided by the concentration initial, that's what the little 0 always means, is initial, is going to be equal to the rate constant, negative rate constant, times that specific time point you measured that concentration at. So this is the start of the integrated rate law equation. What we're going to do is we're going to manipulate that particular expression to get it to fit a standard straight line on a graph. So y equals mx plus b is the form we're going to go for. One of the properties of natural logs is that if you are dividing two variables, you can end up subtracting them. So we can separate this term into the natural log of a sub t minus the natural log of a sub naught. The right side still equals exactly what we want, and we end up with the natural log of a concentration at a certain time point equal to our rate constant times our time plus the natural log of A at time point 0. This is in the form y equals mx plus b. We have y and x. We're going to graph the natural log of A versus time. We can calculate the slope, which would be our rate constant in this particular case. And we can get the y-intercept, or we can set the y-intercept to be the natural log of a sub 0. Using this particular method, we can calculate information. We can calculate specific time points. We can calculate concentration initial. We can calculate the rate constant, and so on and so forth. This all has to be done graphically. This is why we're moving into Excel. This is the first order. From there, we are going to graph the natural log of A versus T. It's going to give us a graph. If the graph is straight, sorry, it's a negative slope. If the graph is straight, okay? So if we take a set of data, we graph the natural log of the concentration versus the time over which the experiment takes place. If it is straight, then you can say the reaction is first order with respect to this particular concentration. That's where we're going. Again, we're going to work on this all day today. All right, a first order process, as we talked about yesterday, says that as the concentration of something changes, the rate changes in the exact same way. You may remember that from yesterday when we were talking about looking at data. As something doubled, the rate would also double. That would mean that the reaction was first order with respect to that particular reactant. Our example up here is our methyl isonitrile being converted to acetonitrile. They look very similar, right? All that's really happening is this part of the molecule pops off, turns around, and attaches itself. Okay, when we graph the straight data, so when we take just A and we graph it versus T, this is what comes out. So this particular set of information is not useful. Right? I can't get the slope of that line because that's not a line. Instead, what I'm going to do is I'm going to treat the data and I'm going to graph, the natural log of the data versus T, and I get a straight line. Woo! What this tells me is that this particular reaction with respect to this particular reactant is first order. So again, this is a graphical method for determining the order of a reaction. It's one of our few. Okay. Next thing we're going to talk about is the second order reaction. Similar type of treatment of data. We're going to change our data to fit y equals mx plus b. In this particular case, we manipulate the data by taking the inverse of it. Again, when we graph it, should have a positive slope with a straight line. If you graph 1 over A versus T, and you come out with a positive slope straight line, then you can say it's second order with respect to whatever reactant you've graphed. Okay. One more type of graph we have to talk about, and that's zero order. First and second are the ones that we're going to be looking for, but also we can have a zero order treatment of our data. Now, yesterday when we talked about a zero order reaction, we wrote a rate law, to the zero. What happens in the rate law then? This just becomes 1, right? That doesn't mean we can't get information about the reaction if the thing is zero order. right? It doesn't mean that we can just decide to ignore it. We can still use zero order reactions to determine concentrations at specific time points. In order to do this, again, we're looking for a straight line in a specific scenario. The specific scenario is just straight up a graph of A versus T. So if you don't have to treat the data at all to get a straight line, and you get a straight line with a negative slope, this would be a zero order reaction. Integrated rate laws are useful for more than just determining concentrations at specific time points or determining rate constants. We can also use them to describe what we call a half-life. Okay? Our example for our second order, I apologize, is a given set of data, right? And we're going to go over this in Excel in a very deep way, in a lot of ways. If we go through this particular set of data, we take the natural log of it, so that we can graph it. The thing that we would try to produce is a graph that produces a straight line, right? If we graph natural log of NO2 versus time, the data does not come out to be a straight line, is what you're being told. So the next step would be then to graph 1 over the data, 1 over the concentration, versus T. When you do that, it did come out to be a straight line, so this is the second order reaction with respect to this NO2. Okay. The last thing that's really useful to use these integrated rate laws for is what we call a half-life. Okay, who's heard of a half-life before, hopefully? All right, so the half-life of something is the length of time it takes for half of your original concentration to disappear, to be used up, etc. Okay, so if we start with 1 molar concentration of something, we want to determine how long it takes for it to 50% disappear. Okay, that first 50% to disappear is going to be a set amount of time. After that amount of time has passed, you have half of whatever you started with left. If another half-life occurs, half of it also then disappears. So our half-life for this particular reaction is about here, right? After another half-life occurs, you're about here, and so on and so forth. So think about the, I don't know if you guys have ever seen the divide it by 2 several times. So after the first half-life, you have this left. Okay, so this is gone. After the second half-life, now you only have this left, right? So this is the first one, this is the second one. If another half-life occurs, you only have half of what was left in that particular thing, and so on and so forth. Right, so you can infinitely cut whatever's left in half, is the idea. Does that make sense? In the starter? Half-lives can occur in either a first or a second order process. For a first order process, the half-life equation is this guy. Don't really worry about the rest of it. It's this guy. Half-life of a first order process is probably the easiest one to calculate. You would have to know that the process was first order in order to use this particular equation. We're only going to talk half-lives for first and second order processes. All right, for a second order process, we get this one. Again, you just want the stuff at the bottom. The one equation. mathematical trick. But yes. All right, I'd like you to get your computers out. I need you to open up Excel on the desktop. Do not do it in an online browser. Yeah. Take time, get it open. Yes, ma'am. Excel. Oh, put it on the board. Oh, all right. See that? The T1 half equals 0.6. Oh, okay. Yep. What's up, David? Computer shortage? Yeah. Okay. And don't remember my Apple. You can't use it online? You cannot use the Excel Online. You have to use the desktop. Excel Online doesn't allow you to insert trend lines, and you need equations of lines for this particular exercise. See if I can figure out how to split my screen. What did I do? You don't want you. You want. You. Label. Anybody know how to, is it to the right? Yeah. Perfect. Okay. Well, you have access to this data directly. So, the first thing we're going to do is we're going to go back to sections 1 and 2, and we're going to learn how to determine an instantaneous rate using Excel. This is one of the problems that you have to do for homework. So in order to do this, what we're going to do for this particular exercise is we're just going to graph this data directly. So we're going to put time on the x-axis, and we're going to put concentration on the y. In order to do that in Excel, when you enter data, you want to put y data on the left, x data on the right. So for us, y data is our concentrations, x data is our time. So you need to go ahead and you need to copy that data down. Yep. Time should be the x. Okay. Time when we do these exercises will always be on the x-axis. everybody get Excel done? Again, can't use the online app. I think you're gonna have trouble manipulating it. Can you not get enough to do it? Alright. I'm gonna change my X and Y to read exactly what they are. And I will remind you that these brackets that you see around something indicate concentration. More specifically, they indicate the concentration in molarity. So anytime you see brackets around a compound, it means molarity of that compound. The other one, I'm going to write time in minutes because that's what we're dealing with. Now, before I move it any further and make any graphs, one of the things I want to look at in my original set of data or my original questions is, do they ask me to do anything in seconds or to change any units? And it looks like it says for part A, calculate the average rate of reaction in molar per second for the time interval between each measurement. Okay. So what it wants me to do is calculate the rate in molarity per second. Okay, so here's the problem. Are my minutes in seconds? No. Alright, so one of the tricks I'm going to show you first is to drag something. So if you wrote it in this box and you see this little, if you hover over it, you're going to see a little white cross. If you see the white cross, that's good. I want you to click it. Ooh, no, I like it. You want to look for the little arrow because we want to move it over. Okay, so look for this little black arrow. I don't know if you can see it. It's kind of weird. That little move arrow. Okay? Then in this column, you're going to write time in seconds. I'm going to teach you how to use formulas. You can do this using a calculator. I particularly will teach you how to use formulas because I feel like that's really helpful in Excel. When it comes to writing a formula in a box on Excel, you always want to start with an equal sign. So I'm in this box right here. What I'm going to do is I'm going to tell Excel that anything in the box to the left needs to be multiplied by 60 to get it into seconds. Right? Do you agree? Going from minutes to seconds, we need to multiply by 60. Okay. So over here, this number is going to be 0, obviously. But if you select that box, it should come up with a B2. So if you hit equals and then you click that box, you should see B2 pop up in your little formula box. Everybody see that? Good. You get lost at some point, you call me over. That's what today is about, is to teach you how to use Excel. Then we're going to multiply. Multiply sign is the little shift 8 by 60. And then we're going to hit enter. You're going to see it stays at 0. Dang it. Cool. All right, so now the next thing we could do is we could enter that same formula for every single one of the boxes below it. Or, the beauty of Excel, see this little green dot in the bottom right of that box? Click. Drag. Teaching me. Yes, ma'am.
On my computer, when I did the thing, it had like a little error button and then it put like value. Yeah, it like dragged the equation part.
I literally just looked away from half a second.
Oh, it's because this value is not reading as a 0.
Zeros.
I think you put like an O.
Literally typing equals.
Alright. Anyone else have an error that needs to be
Wait, how'd
addressed?
you get to the
Yes,
B2
ma'am.
thing? I don't know how you tried.
Say it.
Is you take the circle
Times D for each, and D for each is 60.
Oh yeah, hit it.
This is now coding drag. No, you click that little part in the box. So go
I looked away for like half a second and then I didn't even see how you did like the multiplication.
Sure. Okay, so click that box. So you're going in this box, hit equals. Yup. And then you're gonna go. Yeah. I'll be right there. Oy vey. Oh, I'm screwing it up. Hold on. I'm gonna show you the formula.
I didn't know you could write numbers in a foreign language.
Okay, so go up here. Oh yeah, it's a whole different language. People make a living doing this. All right,
Oh,
so this box should have
Okay.
this written.
Um,
So if you hit equals, then you click that box.
okay.
It'll put B2 in your formula.
Oh,
Then you want to
gotcha.
multiply by 60. So you're going to do shift.
Shift.
This one is the multiplication
Oh yeah.
times 60.
And then
Okay.
just click away.
Hit enter.
Enter.
Then go back up here. You see this little thing on the bottom right? That little box?
Like this, right?
Yep.
All right. Perfect. Thank you.
What's up? So say again.
Honestly, we made that a little too complicated for my taste. No, Excel's like statistics is the yeah, statistics, sorry.
I just didn't think of it. I forgot it.
All right.
Dude, I forgot that this is
Next up is to calculate the rate over each time interval. From yesterday, what is the rate equation? Change in what on top? Concentration. A rate is always over time, over change in time. Okay, so we're not going to start in box 1 because there is no change in time to deal with. Do you agree? Okay. Down here in box 2, we want to calculate the change in rate divided by the change in time. Do we already know what the change in the change in concentration is? We do? Can we figure that out? Using this over here? In an effort to keep things a little bit simpler, I want us to calculate just the change in the concentration. So I'm going to move this again. Getting really good at it. Find your little black arrow on the outside. So if you look at the outsides of the box, there should be a black arrow that you can move. Okay. How we doing? On the MacBook, it's a little hand. Because Mac has to be cute. So the column that's going to be to the left of the rate is going to be change in concentration of HCl. Whoa. Jeez. It's like if you double click the column in between, you see this little arrow. If you double click it, it'll auto size it. And since there's a formula in that one, it like.
I always get really mad with like stuff not fitting in boxes.
Spoiler alert, I'm also going to make you move this box over again. Because we're going to do change in seconds too. So the top part of your fraction is change in concentration, and the bottom is going to be change in seconds. So in this particular box, we're going to write NA because it does not apply to the first box. It does apply to the second box. All right, you ready for another formula?
No.
Sure. How do we start a formula? Change in seconds.
What's the E1 box?
E1 is change in seconds. Sorry, I'll change the size of it. You just have to remind me.
Change. I bet that's like some sort of curse word. Change. No, it sounds like a weird substance, maybe a drug. Change. If it isn't taken, I will make it into the first drug. machine.
Remember, we want to go from minutes to seconds, so we're gonna multiply.
It's a small boat used on a Nile. Joel, did you know Thames is a small boat that's used on the Nile? Yes, just Google it.
Should be negative,
It's a noun.
shouldn't it? Those rates are gonna be negative because
Oh.
the second one is the first
I
one.
thought you were just trying to get my attention.
Oh, cool. Alright, can we move on?
No.
What?
Oh.
Alright, moving on.
Thank you.
The change in the concentration in HCl is going to be a formula. So we started with
Yes.
equals. Then we're going to select the second concentration down.
What?
We're going to subtract the first concentration we started with. So it should say A3 minus A2 if you were following along with mine exactly.
Yeah.
A2. It was A3 minus A2. Then you hit enter. Should your number be negative? When we do changes in concentrations, it should be final minus initial.
And then enter.
And then you're going to hit enter, and you should see the same number I have. Yes.
And then green box.
Yes, you can.
You get this all the way down.
Yep, and we are going to do it all the way down. If you click that box the same way you did before, and you drag, you're going to get the numbers all the way down. It will, listen, you can double check it's doing what you want it to do if you go into the second box down. So the one right below negative 0.27, it should say A4, which is this one, minus A3, the one right above it. Okay, you can check your concentrations as you go. That's crazy. Super useful. All right, we got to do the same thing for change in time. So we're going to, again, start with a formula, which means an equal sign. We're going to select the second time point, subtract the first time point. So it should be C3 minus C2. And we're doing this in seconds, remember, not in minutes.
And then you screw it up.
Then you can just delete it all. So backspace all of it and start over. All right, you're going to hit enter. And you're going to drag all the way down.
That's pretty nifty.
Wait, what was the two things she selected?
I like
I was paying attention. Oh, yeah. What was the two things?
The more you use it, the more you'll like it. But initially, it's kind of rough.
I want to see her.
You're also getting the you're also getting the
C2 minus C1.
C3 minus
that I will only teach you
So it's 3,
things I
2, 4,
need
8
you to
minus 0.
make basic formulas, make graphs.
C3 minus C, right?
All right. Our
C3
next
minus
step
C2.
is to calculate the rate at each of those time points. And we just said, we did this to make ourselves easier, that there is no rate for the first one because we just started the reaction, right?
How is the number getting smaller if you're subtracting by 0?
You're not subtracting by 0 every time.
Okay,
Okay, so like look at
previous
this one. So you look at this one,
Yeah.
right? It's a C4 minus C3. So that's this one minus this one.
Okay.
We want to know the difference between each of the closest time points.
Okay.
And that's what we're calculating.
I was confused because the final minus initial, so I thought like we subtract the first and
No,
Isn't that right, Chasey
No,
Penny?
because we want to know the difference between
Yes,
each
sir.
set of
Okay.
times. Does that make sense?
Yeah.
We have
Daddy
each
will
set
not
of
I
calculations.
will
Okay.
Yes.
This one, you're doing the second one minus the first one.
Okay.
Then for the next one, you would do the third one minus the second one. Then for the next one, you do the fourth one minus the third one. Now, remember, if you just set up the first formula, you should be able to drag. Say again? No, you should. So if you do this one, right here, you got the A3 minus A2. Then you can do that thing where we click the box and we drag. Did you do that?
Yeah.
Okay. Then you're going to do the same thing for seconds, but you're going to use the C3 minus C2 as your first one.
Okay.
So it should just be the exact same number because the first number was 0, or the second number was 0. Okay. Now we need to calculate the rate, and that is going to be change in concentration divided by change in time. So again, formula. Which column represents change in concentration? D or E? D. Then we're going to divide it, according to our formula, by E. Then we're going to hit enter.
Oh, wow.
And then
Which E is it?
E3, yeah.
Okay.
You're going straight over for these two. Yep. Then we click and we drag. far?
Sure.
Okay, so part A of the problem,
Part A.
let me come back to,
Part A of 12.
let me come back to our example problem real quick. I'm gonna, hide my Excel real fast. Okay.
That was section 1.
Part A of the problem was to get the rate of the reaction in molarity per second for each time interval. We did that. Part B says to calculate the average rate of reaction for the entire time for the data from 0 to 430 minutes.
There are tears in my eyes.
So instead of looking at rates over small time points, now we're going to look at the rate from the beginning to the end. And this is a straight calculation. Okay. So we're just going to do this in 2 boxes. Down here we're going to do part B. And then I'm going to tab over. I'm going to do this in several boxes, but you can do it all in one box if you like. Part B. Average rate for entire experiment from 0 to 430 minutes. And then down right below that, I'm going to give an overall calculation. So I'm going to do the change in concentration over the entire thing. Change in concentration. And then I'm going to do change in time. Now the part about Excel that can get kind of rough is the columns have to get bigger every time so that you can see what I'm writing. So if at some point you can't read something, just say, hey, what does it say in column F on number whatever. Okay, so I need change in concentration from the last time point to the first time point. And I'm going to do it right under where I typed in change in concentration. So I'm going to give it a formula. I'm going to say equals the last time point minus the first time point. The whole thing is what we're looking at, the grand scheme.
Minus the first one?
Yep, so the last one minus the first one. You get negative 1.27 if you enter it correctly.
Yes.
Sorry about it.
Yeah.
Okay, so hold on. Look up here. The formula is the last concentration minus the first concentration. Yep, you put the equals in there first. Always equals if you want it to do math for you. Okay? You have to start a cell with an equal sign if you want it to do the math for you.
It's minus.
Hey, so if you click, hey, Olivia, that's a good question. I was asked, how do you make the boxes bigger? Up here, between 2 columns, you can see this black arrow with 2 heads. You can go like this, and it'll make the column bigger. If you double click it, it'll decide what the size needs to be. But I don't recommend it. Okay, now I'm going to do the change in time. And I'm going to use the seconds still because our first one it wanted it in moles per second, and we went through the whole battle of getting everything in the seconds. So for this one, I'm going to do change in time in seconds. So again, I want it to do the math for me. So I'm going to tell it to subtract the biggest number minus the smallest number. Using your brain, you can see that it's just going to be whatever the biggest number is.
No, I didn't expect that.
All right, time to do the actual math here. Our goal was what is the average rate over the course of the entire reaction.
So she hit it.
It won't
It's
work.
like, are you
It won't work. It won't work unless I
She
do it.
doesn't wanna
Excel
do
is
the
not
math.
easy for everybody.
Like, sometimes it just sticks.
How about Excel
Say
is
again?
easy for absolutely nobody?
So we did the change in time in seconds of the column above.
Letters don't work.
Have you taken it in here?
Just snack it. Yeah.
Just keep snacking. I think I spilled coffee on my phone, so I
Yeah,
think
if you get cleaned, it'll be one of serious. And they won't charge you a ton of money. I mean, that's worth it.
We're at Best Buy.
No, you'd have to go to a private.
Those geeks won't do it for me. They
They're
will.
very,
Or they will like.
they will, but they will also charge you a solid $300.
Yeah, they're dumb.
Okay.
They're
All right, listen. Our average rate is going to be the total change in concentration over the total change in time. So one more formula. I'm going to do the change in concentration that I calculated. I'm going to divide it by the total change in time, which is going to be that one.
He can.
If you're using the exact same cells as me, the formulas will match. If you are not, you're gonna have weird
I
numbers.
am using same.
Yep. So
I'm using
No.
Is this
Continue?
the end? Have
Okay.
we reached the end?
then we hit enter. That was part B. We still have part C.
Really?
Every time we do.
No, I didn't get that. It won't take us long every time we do it, as long as you're learning how to do it. You're gonna work on the integrated rate laws in class, but for your homework, you'll do that.
You're
She's gonna be like, all right, set up the conversions. I'm gonna be like,
For the integrated. The integrated laws are like yeah.
this makes me just want to like throw up in the ball.
All right. Real quick, everybody, I'd like to point a couple things out. Over here in the rate column, do you see the E and the -5? Okay. What does that mean? Means times 10 to the -5th. Okay. We can manipulate what these look like by changing the format of them. I do not care what your numbers look like. What I care is that you can interpret the number. So if I ask you what the average rate of this reaction is, you better be writing 4.92 times 10 to the -5th. Do you understand? Okay, let's move on to part C. For this type of problem, again, this is still section 1-2. We're trying to get a graph of HCl versus time, is what it says. So we just want to graph the concentration of HCl versus the time to determine instantaneous rates at specific times on the actual graph. Okay, this one says determine the instantaneous rate at moles per minute and moles per second. We're going to do moles per second for our graph, and then I'm going to assume you can convert seconds to minutes in order to determine the specific time. Because you can go from minutes to seconds, I'm sure you can. All right, so in order to make a graph, okay, what we want to do is we want to graph this column versus this column, right? We want to figure out what the rate is at specific, sorry. What did I say? HCl versus rate or HCl versus time? HCl versus time, cool, okay. So we want to graph this. So we're going to click and drag. See the little white arrow? Looks like a little like,
Plus.
whatchamacallit?
Add.
I did include HCl when I clicked and dragged.
Where do we move it?
All the way down to the bottom of the column. So like, you're gonna click here at the top and drag all the way to the bottom of the data. Okay. Next thing you have to do is select another column at the same time. So you wanna hit the control button. My Mac users, I think it's the command button. We'll test it. Yeah.
It's the command button.
Then you wanna click on time. So you wanna hold control down because you're trying to do two things at once. You know how you select data? You want to select two columns at the same time.
I have not yet dragged it on.
Okay, can I help? It will help you. So we're gonna select all of HCl, and then we're gonna hit control, and then you're gonna go over to time. You see this column over here? Time in seconds. Click and drag the same way you did. Then you can let go of everything. Once you have those two columns selected, you can let go. If you are at this point struggling, just sit there quietly now. Come help.
That's really directed.
It was directed at you. Sit there quietly and I'll come help. All right. Next thing, up at the top of your Excel screen, you see insert. Go to insert, and you want to find this little box that says insert scatter. Click it and click the first option. You're good. So go over to insert.
It's a graph.
Oh my gosh, something that
And
makes
then go
sense.
to insert scatter. Now, when you select one of these, you are welcome to select the one that connects the points. You can also just do the one that does not connect the points. I would recommend the one that does connect the points for this particular graph because
You
your
should click
goal
the
is to
first one.
interpret the graph at different times.
Oh, it's broken.
You said click the first one.
It flipped them.
Like that, like waiting.
Crap, I need to flip them. Alright, I'm going to delete my graph. I shouldn't have done that.
Oh, it did flip. So don't do that.
Start with that.
So start over.
Well, I'm going to see if you can select them in reverse. Hold on. Because it put them on the wrong. That doesn't work. Okay.
What do they do?
All right, guys. You ready?
No.
It's the advanced course.
No.
You're gonna click and drag this column. Then you're gonna
Click it
copy
again.
it. Hit Control C.
That's plagiarism.
Trust me. Then you're gonna move down here to an empty spot. I want you to copy the whole column. You should see this thing happening. Once you've copied it, you should see the little arrows. What's up?
I don't know what happened.
No.
It put hashtag ref.
Yeah, hashtag ref.
Yeah.
With an exclamation point.
So that's because you skipped forward. All right.
Does it matter what boxes are in?
It does not matter, but before you actually hit paste, we have to go and we have to pick the right paste. I know, this is, like I said, this is the advanced course. When you go to hit paste, you need to hit the one that says paste values.
Yeah, what?
So on the home screen, there's a little paste button. Select underneath the paste. Do you see how many options there are for pasting? Select the first one under paste values. That'll just do that, okay? So again, you good?
Yeah.
What's up?
I started taking this and like after German.
here to dock yet, so you're gonna
That's not fun.
Oh.
and then
It's all funny games to pull in the lock.
Okay, you're good? Did you get it?
Of course I did.
Can I see it?
Sure.
Thank you. Good? Good? If you did not get them pasted, could you please raise your hand? Okay.
I think we could go.
So what we're gonna do, we're gonna select the whole thing, so click and drag all the way down. Make sure you see the white arrow if you want to copy. Then you're, the one you had, you see that all the way down? Okay. And you're gonna Command C. Now come down to an empty one.
So it's literally just talking.
Except you have to do this part. So on the page, you see that little arrow next to the page? So you can do that. You're good?
Do that for the
You're
HCL?
good?
What happened with the HCL?
What's this thing right here?
No, you're gonna have to flip them. Because the graph didn't work. This is why we're doing the advanced course. Control C.
I'm gonna
We're gonna get down here. And we're gonna paste it. By paste, we're gonna do it. Yes. All right, you're gonna paste the column for HCL directly to the right of it.
That was a lot easier than I thought it would be.
Those of you that feel comfortable doing it, do it. So click from the top, highlight, Control C or Command C. Then you're gonna come down into the column right next to time. You're gonna paste values. Not that it would matter. If you just hit paste, it should do both. Okay, now we're gonna make it.
Is this correct?
I'm so mad at this graph. All right, so we're gonna click.
It's a bad one.
This part's a little bit different, so you're just gonna click and drag the whole thing, highlight both columns at the same time. Then you're gonna go insert. On the scatter plot, remember, I want you to pick the one that has the lines.
It is exactly.
Okay, the values on the left side should run from 0 up to 2. The values on the bottom should run from 0 up to like 30,000. Right? And our values on the x-axis are time. The value on the y should be concentration of HCl. All right, so we are not done with this graph. We are never done with graphs until they are properly labeled.
So now we gotta label the graph.
So we need to label our graph. Up in the top left of your Excel, you should see a thing that says Add Chart Element.
Go
You
underneath.
you did some of this last year. This isn't
Wait.
all of it. All right, underneath Add Chart Element,
Um,
and every single one of you should have Add Chart Element if the graph is selected. Go to Primary Horizontal and click it. Horizontal, axis title. There you go. Okay, now you're going to enter your primary horizontal axis title, which is going to be time in seconds.
Thank you,
Don't just write seconds, write time in seconds.
Time seconds.
That's how I write it. Time, a parenthesis, seconds.
Are you-
Do the primary vertical next.
What?
The primary vertical should just be HCl in those brackets.
Oh, I know. Oh my god.
Alright, is this the end? No, you know.
I feel like this is
I'm
science.
here.
So now do the current elements, yes. Alright, after you get the axes titles, the primary horizontal and primary vertical, go ahead and take yourself a 4-minute break. And then you're back here. Quickly, please.
That's not time for coconuts. Run fast, yes.
So select too, yeah.
Hurry, child.
I'm just gonna leave it.
What's happening?
You don't know what that means, do you?
What is going on?
Bumping coat.
Patrick, you broke it!
How? I don't know. Let's go with this. It was there like 2 seconds ago.
No. I'm ignoring you still. Wait, what? I'm ignoring you from now on. Okay. I'm only typing telegraph messages from you, so once you set up a telegraph line.
You can do the same things in
Hey.
your as in the you see on
Nope.
the sheet?
No.
Okay, good. Alright. When you're done with your graph, you can answer those 2 questions. One of the questions was, what is the concentration at time point X? The goal of this type of graph from your homework set, listen real quick. The goal of this type of graph from your homework set in sections 1 and 2 is to be able to look for a specific time point and extrapolate what the concentration is at that time point. Does that make sense? So this is just read the graph. That's why I wanted you to make the one that connects. Yes, Joel. Yeah, be fast. What'd you say?
Why do I have 2
Chase?
graphs? I was just only have 1 graph because for some reason I have 2 now.
Why do you
I
One
don't
of
know.
them is wrong. So remember, we
Gotcha,
want the one that
so-
has the big numbers.
Yep.
Okay. So,
How do I change this from out of caps lock? Because caps lock isn't on, but they take it.
If you try turning it on.
oh, here we are. This is a problem. This is supposed to be 1.5. There you go. Your graph looked weird. Okay. So, did you make it black? I don't know how to change that. I'm not sure. How are you doing? You just get to use it again. Because we're going to move into a new one next. Now we have to learn this stuff. Yeah. But we've already talked about how to manipulate data by doing formulas, right? So all we have to do is tell Excel to do data manipulation and then graph. Anything we want to graph. What's up, Shelby? 1 second. Teach it to a lot of different people. Yeah, that's what we did that second. So we started, so we did the difference.
Every single one of these strikes are violent.
And then
Wow.
for Excel, so like you see on my graph, if I said, what is it? They just put the numbers into formulas.
Wait, who did you get this from?
Like a spreadsheet, but not a
Results on the strength.
You see what I'm saying?
And she uses Word for the spreadsheet.
How about the fact that 9 people got killed?
Okay.
Yeah, so I'll tell you how, but at the bottom, you're gonna hit new sheet.
So rude.
Alright, we're gonna start the instantaneous rate practice. Or, I'm sorry, the integrated rate loss practice. That was instantaneous rate. What's up?
Nothing. It's going. I changed the
Wait, that wasn't 4 minutes.
Okay.
That was 30 seconds.
Okay,
That
so
wasn't even close.
one of the things you can do, and you will have to do on your homework set, is to copy and paste those graphs. How do you think you copy and paste a graph? You probably have to, I don't know, right click or on it, and then hit copy on the overall graph. Right click. You can hit copy, and then you can paste a picture.
It won't.
You you know how, take snips or pictures of your desktop, and so on and so forth. Again, a graph is not complete until it has axes titles as well as a title on it. So up here, you see this little box, right? How could I change that? If I click into it,
Location versus time.
it's HCL versus time. Thank you.
Did you
Yeah.
drop is this like what's in this called?
The constant battle of
What we just did?
Versus
This is the
time.
instantaneous rate law, or this was the instantaneous rate determination. Yes.
My computer's crashing again.
Why?
I don't know. It did this to me.
Is
We
it
like-
cold?
If that was the
Shut it
title of
down.
the movie, I'd
Can you
watch it.
restart?
I'll check.
HCL versus time.
Yeah.
Are you do you have like the spinning ring on the deck?
No.
Yes, and the last time I did was my whole
Right
computer
here.
crashed.
Hold for so give it a
It's
second.
like Oscars.
Give it a second. Everybody take a deep breath. All right. So we're going to continue, everybody. Let's talk about the next thing. I need you to, at the very bottom of your Excel, click New Sheet. So you see how there's a Sheet 1 and then there's this little plus button? You should hit that and then you should be in Sheet 2. Okay? You can. If you double click them, like,
Graphics.
Okay, so what we're going to do is we're going to copy data over, just like we did at the beginning. This one is the integrated rate law determination. So in order to do this, we need to get time and concentration. That's where we have to start. So you want to copy time in seconds in the first column, and then concentration and molarity in the second column, just like we did before. Copy it exactly how you see it, please. Time first, concentration second.
Could you zoom in like a tiny bit? I guess canvas do it.
Oh no, now it won't slide in.
Okay, give me a second.
Like, the more you zoom in on canvas, the blurrier things get.
Really?
Yeah, really. If you download it, it doesn't do it, but if you do it on canvas, the blurrier it gets.
I think it's because Canvas is like a preview. Do you know what I mean? It's not like the full file in Canvas. It's just
Low
a
quality
preview.
the cameras are on canvas, but people always choose the low quality option first thing because there's no product to change it.
I'm ignoring you.
Sorry, you have version of sheet that crashed my computer.
Telegraph.
It gets
So, telegraph line.
It crashes again.
Okay,
It
we're
shouldn't.
good.
It shouldn't.
What'd you say?
Okay, so now do a new sheet
You can't hear me.
and start getting this data out.
What's an update? I don't think he's doing well. My computer's not like
I think you two should have sitting next to each other.
You're country.
You and Aiden.
Yeah, I found it funny. Like, the keynote was complaining about the local video things, and then they don't show
Yeah, on the
high
video.
quality one.
Because you don't seem to be getting much done over there.
I'd love to sit. You'll have to select high quality.
No, well, we just started. Okay.
Wait, you.
Mr. Blue
I
from
was
the
just
stream
looking
his
to see
YouTube
what the
videos.
instructions.
50 pixels.
It's like a slideshow. 5 seconds later.
Oh, up at the top.
It's like a shittier Twitch.
Hey. I don't like it.
She yelled at us. I'm not sure.
Yeah, it was definitely.
Okay. How we doing? We good? We got it?
It's just saying what exactly did you
Okay, so when you do integrated rate law problems, you will be asked to produce 3 graphs.
It's just an acronym.
You will be asked to produce a first order, a second order, and a 0 order graph.
I'm gonna use that.
Hold
It
on.
just says not responding. I think Excel just like crashed.
It's not.
It's because
Excel is
we're
like a
using-
soup, like it's like saying Word is crashing.
Should I
Word
Oh, Word
Word
Stop.
has crashed in the
Wait,
week.
Word is
Word
crashing.
documents,
We're all
like-
using it. So
Should
I
I
will call
wait
my
for the
story.
program to respond to close
I'm
your
ready.
call your what? Oh wait. Everything's gone downhill since I edited the play for them. Now my computer randomly crashes.
Is your computer full? Is that why?
No, I just deleted my whole
I
iMovie.
Okay.
opened up the Chrome.
I'm moving on. Let's go.
Alright.
I don't hear all the fouls. That's why I wonder.
7 and B3.
7, 8, 7. And B3.
Yes, column B3 F vector 7. And a 9 after the next one.
No. We want this one. Sorry, just exactly as you see it. Because last time Okay, so first things first, we can already make one of our graphs. When we graph integrated rate laws, you need 3 graphs. Graph 1 is going to be 0 order. Graph 2 is going to be first order. And graph 3 is second order. Okay, before we actually make those graphs, let's talk about what they should be. In the first 0 order graph, on the y-axis, we should graph the concentration of whenever you're I'm sorry, it's just funny to listen to Jewel like slam her computer every once in a while.
She
She'll be
does
like,
it every
"Bam!"
day.
It's so funny. Okay. We should be graphing the concentration of our substance directly versus time. That's our first one. Okay? Our first order graph, according to what we have on the board, should be the natural log of the concentration of A versus time. And the last one we should have should be 1 over A versus time. Now, hopefully you see that the concentration of A in this particular case for our graphs that we're about to make is going to be the concentration of NO2, right? All I did was use A because that's generic, but you can put any substance in here for A. For us, we're going to put in NO2. Okay, so in order to graph first and second order, we need data to be manipulated. If I want to graph 1 over A, I need to take 1 over A. So we're going to do the first order manipulation first, which is going to be the natural log of, for this particular exercise, NO2. Okay. All right, you ready for a formula?
No.
So we're going to hit equals.
No means no.
Then we're going to hit natural log, ln, it should pop up already. In order to use this function, because this is a function in Excel, we have to put a parentheses. So you should have equals ln, and then the first parenthesis, the open parenthesis. Then, what number do we want to take the natural log of? The first NO2 concentration. Do not hit enter yet, you have to close the parentheses. You're good, I'm not going to move it. Remember that anytime you look at a box, if you like select that box, the little formula bar up at the top should also have the formula that you typed. So up at the top of that box, it will say equals the natural log of AB2, or B2, sorry. Once you're done with that, you can hit enter, and a number should pop up.
That's not what I want.
If you do not close the parentheses, Excel will scream at you.
You did. It said
Hashtag
It'll say, "Hey, this is wrong. You need to fix it," and then you just say, "Okay," and then it'll fix it for you. Okay, what can we do next? Click and drag. Patrick, is that your favorite part? Okay, before we do our graphs, I am also going to do the last manipulation for the second order. So the first thing you should do when you're doing these integrated rate law problems, because you're going to work on these today and tomorrow in class, you're going to do some practice ones. The first thing you should do is manipulate all the data, right? Do the natural log column and do the 1 over column, then create the graphs. And you'll get faster at it as well. Okay. For this column, I'm going to title it 1 over the concentration of the NO2 This is just a name, okay? And then we're ready for a formula. So we're gonna hit equals. And then we're gonna make it say 1 divided by. Remember that you wanna do this concentration, the original concentration of NO2. Do not pick the natural log equation. Should still be B2. Oh no, because I'm not using mine. Once you have that, enter. Then what? Drag it. All right.
They always come up.
Woo. Okay, we're ready for our graph. And what I'm gonna do is I'm gonna try to keep this sort of organized on my page. It gets harder the longer this goes. So I've got the zero order graph. I'm going to put it down here. I'm going to put my first order and then my second order over here. Okay, so my zero order graph. In order to do that, I'm going to select the first 2 columns, just like we did before. And I'm going to go to insert. This time you're going to just insert a scatter plot. Do not put the ones with the, do not pick the one with the lines. We just want the straight scatter plot. Okay, pick that. Click.
So the zero order is just the straight up data?
Correct. Straight up data, the 2 columns next to each other. NO2 versus time. You can name it NO2 versus time. You can also, I would say, zero order graph. So you can keep track of the orders. Okay? Remember that a graph is not done unless it has titles. So get the axes titles in there. On the Y should be the straight concentrations. Anytime you're doing anything with concentrations, I would just use the little brackets. If you use the brackets, it tells me that the unit is molarity, right? If you do not use the brackets, it does not give me information about the unit, but if you use the brackets, you don't have to include unit. The bottom should be time. Say again? I put just concentration of NO2 because that's what I use, that column, okay? And then time, when you do time, you always have to give me a unit in parentheses. If we're dealing with seconds, we're dealing with minutes, etc., etc. This particular data set had seconds. Okay, so here is my graph. Everybody sees it, right? Okay. So I'm gonna move this for the purposes of what we're about to talk about. In other words, I'm gonna make this chart bigger because you have to insert a trend line next. Anybody remember how to do that? So add chart element. I moved it. You're not doing that part. I don't want you to do that part. You don't need to do this. I moved my chart into a new sheet. If you really want to do it, up here on the top right, when you have the chart selected, you can hit new chart to new sheet. Just make sure you keep track of what those charts are. So like in the bottom, you know how we said we could name the sheets? You can move everything around in Excel, and I just don't want you to stress out about it.
I started
Doesn't it? Either way. Okay, so now on my chart, when you have it selected, make sure you're in the little design tab. We want to insert another chart element. In this case, we want to insert a linear trend line. So go up to add chart element, click trend line, and then go down to linear. And you're going to see a line pop up. And you're going to click it. Okay. Everybody find it? We need some help. We need help. So go to add chart element. Go to trend line. And go to linear. Everybody, anyone else need help? Good? Okay. So this line is not very helpful unless we can get information from it. Okay? What kind of information can we get from it? Hi, everybody. Well, we need to figure out whether or not it actually fits our data, right? Okay. The poor, like, cool. Okay, so on the data, if you actually click the line, you should see that points on the line itself are the ones that will highlight. right click on it and go to format. You should see this thing on the right. So right click on the line itself and go down to format. My Mac users are keeping up with the weird differences.
Control click.
Dang, Gavin, you remember doing this, huh?
Okay.
You don't. You're fine. Format chart line.
If you just click two fingers
Or
on
two
the
discussion things.
transient or whatever, it'll
I
bring
didn't
it up.
know.
I got that. Okay, so go down to the bottom of the format option. I want you to display the equation, but I also want you to display the r squared value on the chart. And then you can X out of the format, because it should just be on your graph. Alright, I need to edit this. So, again, when you're in the format, on the right, you're going to see format trendline options. At the very bottom, display equation and display r squared.
Nice.
I have to do something.
Wait, what's the R squared value?
That's a value that we're going to talk about right now.
Okay.
Okay. This is the equation that mine displayed. Yours should probably be exactly the same. We're manipulating the same data. Okay, the first equation is the equation of a line, straight up y equals mx plus b. M in this case would be our slope, right? Down here, we have a value for r squared. R squared is used in statistics. Who's in statistics? Yeah. R squared is used to indicate how linear something is. So the closer to 1 r squared is, the more likely what you're dealing with is actually linear. Here, we see a value of 0.92. That doesn't seem terrible, right? That seems kind of close to 1 in your mind. Well, the values we want need to be something like 0.995 or greater, because that would indicate complete linearity. So this is actually not a very linear relationship. This tells us how linear the data is or how close to linear it is. In science, we want this value to be very, very, very close to 1. Sometimes it'll pop up as 1, and that's good. Okay? All right, so what this tells me is that this reaction is probably not zero order. Now, could I have just looked at the data and seen, like, it's not very linear, it kind of does the, like, logarithmic thing? Sure, but you are not the tool we need to determine linearity of data. Sorry, you're flawed, you're human. Math is going to do way more for us, okay? So this is not the graph we want, but it is one of the graphs you have to make for integrated rate law, because when you're trying to determine the order of a reaction with respect to a specific reactant, we need to prove that it is not the things we think it could be, and it is for sure the one we decided it. So the next step is to make another graph. Our next graph is going to be the first order. So we're going to do time versus natural log. So click and drag, and then do the control thing. You need to select those two columns, time and natural log. Don't leave it. You're going to, so like if we were doing this on an actual assignment, I want you to copy and paste that. So when we do our practice towards the end of class today and tomorrow, we're going to copy and paste the graphs you make under first, second, and third.
And this is
First, second, and zero. The next one we're making is the natural log graph.
Hey, I got hashtag no.
The natural log. Yeah.
Oh wait,
LN. Not IN. LN.
We're putting I on.
No, he was just like, it's IN. Okay, it looks like IN. Because Calibri.
That's great.
Because Calibri.
Hey, I got hashtag no.
All right. So, select your two pieces of data. You go to insert. You're going to insert the scatter. Yours is going to be control. So select the first column and hit control and select the scatter.
That's not what it's supposed to look like.
They keep Julie keeping up with you. Okay. All right. Once you have the data in front of you,
Something went very wrong.
No, just those.
What is this?
Make sure you do what we're supposed to do. You need to label. If you need help, you answer. You raise your hand. From this point, you should be feeling pretty good about inserting graphs, adding the elements you're supposed to have.
I have no idea.
There's something wrong. There is something wrong.
Yup, there is.
Hand raised.
What's wrong?
My numbers do not match. When I copy pasted, they do not. And it said hashtag numb, and then I fixed it. But then the
Hashtag
numbers
numb.
are
Oh my god. You don't have to move this. Hey, you can just copy and paste it. You can just select it.
Wait, I didn't know how to pronounce it.
I thought it was
Let's
Calibri.
Okay, so let's do Calibri. I just insert graphs.
Calibri?
So we're gonna hit this.
As in the 22 Super Calibri.
I was like, great, oh, found it. It's in the ad.
Research is a huge one.
Just give me one option.
Okay.
She doesn't have a bachelor.
Notice that both my hands.
Remember that you need to label your axes.
It's in, actually.
We are going to create the second order just to double check it.
I'm gonna do it.
Again, I'm going to move my chart into a bigger area so that everybody can see it up close, but this is my first order graph.
How do you get to the,
Why is the font so small?
Calibri.
It's like Howler.
I thought it was Calibri for the longest.
Oh, really? Oh, I mean,
Calibri. I just didn't even know.
How do you get to the
Calibri.
Ooh. So you remember you're gonna insert the trend line, then you're gonna go to format the trend line by right clicking on it. Okay, so remember you're gonna do the chart. You should be on the add chart element
How do I get the line?
on the left, and then go down the trend line and go to linear. Okay.
This happened like 5 times today. No,
What's she doing?
Mine.
So remember, once you have the trend line in there, you've added it through the chart element, right click on the line and go to format, add the R squared and the equation.
Why does it look bad?
I don't know, what'd you do? Like, why does it look like that?
Yeah.
It always will auto, scale from 0.
So can you rescale it if you want to?
You can, and I can show you how to do that if you really want, but right now,
No,
it's like nitpicky, right? Like what we need is this, we need the equations. The whole reason we're doing this is because we need these equations. This is my first order graph. I like to move my graphs into new sheets just so that you guys can see them, but you should have an equation and an R squared value that look like this. You go ahead and move on to the second order graph, those of you that feel pretty confident about making graphs, because you do need that third graph.
Oh, it's done.
So you add the line. So in the, you know how you do the add chart element?
Yeah.
So go to add chart element and go to trend line. And then pick linear.
You said 1 is rating.
You want to get to 1, yeah. What's the second one?
Okay. For the second, is it or wait?
Insert.
Insert
Then
the
you
scatter.
right click on it. I was trying to right click on it. Right click on the line.
And then we do the equation and the R squared.
I got it.
The third one, so it's the time and 1 over. Remember, second order is time versus 1 over concentration, yes. On all three. All three of them should have linear trend lines. Good question. Your second order graph should also have a linear trend line with the R squared and the equation. Look at that. How good.
Well, did you figure it out?
Yes.
Isn't time up to, hold on.
Oh yeah, it does.
It does, right? Doesn't it go up to 300? It goes up to 300.
What's this first one? Like,
Your time
the
is
first one. No, that's the first order. Because that's how. It is the logarithmic one. That's
Okay, so let's go back to your data.
and you just put that on the second page.
Oh my god, midterm is.
Don't even talk about it, seriously.
My grades aren't ready for that.
No.
Oh, yes, it does, because this one's supposed to be up to 300. This one's supposed to be up to 350.
Dude, it's been like 2 weeks.
Midterms are February 6th.
Midterms are 4 quarters, 9 weeks, and midterms are 4
Dude, my history grades it out.
Okay, how we doing? Third graph.
It is a quarter.
Third graph, yes. Okay.
Second order done.
Second order done. Did you get your R squared?
Yes,
What
I
is
did.
it?
I got R squared equals 1.
There you go. Okay. So let me make my graphs real fast, and we can do some interpretation.
We're gonna end up living with you.
Oh my god. What did you just say to you? I don't know, but you're on fire today.
Huh?
So you're on fire today. That's all I'm gonna say.
How do I add things?
You're gonna do this about 15 more times.
Today?
Oh, just in general. Moving forward, like between today and like next week, we're gonna do this a lot. Okay. Alright, so I'm
What
gonna
if we
insert my
don't have any
timeline. To save time, I'm not gonna.
What labels do we throw in here?
Michelle, what's this
Yeah.
sheet called for the problem that we did? What should we
The
do?
one we just, I would say integrated rate law
What was the last one?
practice.
Did we do the daily two together?
Both?
What was the last one?
Sure. You know really good together.
Okay, good, because I know I'm not the only one in the room that is struggling. I did not need to say
Sure.
Michelle, what's the last
All
one
right.
we did called?
Huh?
What's the last method we did called?
That was the instantaneous rate determination. Good question. Okay. All right, so here's my equation. So let's go through our charts real fast. Obviously, it's a second order reaction if you're looking at the R squared values.
Oh,
When?
April 1st. Early dismissal.
Yeah, right.
Is that an April
This one?
Fool's joke?
Heavy for.
These are the constants, it probably says equal pools.
Joke's on you, I'm gonna be in Florida.
Did anybody ask?
All right, so real quick, let's look. Zero order graph had an R squared of about 0.92. The first order graph had about a 0.98, so it was getting closer. Our second order graph is going to be the one that we would choose as this is the reaction order. This particular one, because it has that R squared of 1. The next thing we have to do is we have to interpret the information. Because one of the things we can get from this equation, yes?
So the one we want to use is the one that's closest to 1.
Correct. Correct. Yes. The one you want to use is always going to be the one that's closest to 1, if not exactly 1. So, what we're going to do next is we're going to interpret this. So I'm going to copy this graph equation down. We're going to determine something from it. So my second order graph has a value of this. And I'm going to go back. So now you have the graphs and we've proved what we just said. The next thing we want to do is actually interpret that information. Because just knowing that is not the end of any of these problems. One of the questions you will commonly be asked is, what is the rate constant? of the reaction. So the first question is, what is the rate order? And we said it's got to be second order, right? The second question we're asked is, what is the rate constant? Okay, so the rate constant is going to be K. In a second order reaction, we can get a couple pieces of information from this reaction. So, first is, what is K? Well, in this particular case, since K is positive, K will just equal the slope, which in this case is 0.5431. So from here, if we use the rate law that we talked about yesterday, we would write this, assuming there's nothing else that we know about this reaction. Because we know how to write rate laws, we know what K is now. If we wanted to, we could determine the rate of this reaction at any concentration, because we now know the constant of the reaction. Okay, so this is something we can use to indicate what we know. Okay, this is one thing we can do. The next thing we can do is, what is the initial concentration? In other words, the initial A naught. Do you see why? Anybody? How am I going to do this? We can set this equal to each other, right? Because we know that this is in the form of y equals mx plus b. We know the y-intercept given the equation we were given. So we can solve for A naught. So in this particular case, I'm going to erase this real quick. Huh? A naught. A naught. A naught, not means initial. Sorry. It means initial. So remember, this is like from that original equation is its initial. We can write this. Do you agree? We said that this is the form of y equals mx plus b. This is b, right? Yeah. So we can set b equal to 1 over the initial concentration because it's a second order reaction. What's up?
Oh, I thought you were like solving for something, but you're just saying that they're equal.
Well, I'm saying that we're here. Can I just say that the concentration of A is equal to 99?
Yeah.
No.
Oh, no.
Because it's over 1. No, not A. No, guys, the term not implies initial. So this little 0 that you see, this little 0 you see in every single one of these different reactions means initial. We talked about that. Because A naught is simpler to say than initial A. Yes? Yeah.
Not A equal the number because you have to multiply to get rid of the 1.
Yes. So from here, you actually have to do a manipulation, right? You'd have to multiply over and then divide by 99. So it'd be 1 over 99 is the answer. It's like 0.01. So yeah, she's right. She's right. She's trying to say, wait, we're not done.
Wait, the rate law of this concentration is rate law equals K.
Times NO2 squared. Yeah, that was from yesterday. Yep. Yes. Yes, you do. Yes.
But then you have to divide it?
Yeah, you'll see. Hold on. So here we are. We said that this is true. We said that the y-intercept is equal to this because it's a second order reaction, correct? Next thing to do is figure out what A is. So let's do some algebra. By multiplying both sides by A, I'm going to get this. How do I solve for A? Yes. That's exactly what you do is you reverse them.
If we're solving
have to do this. You can't just multiply to get rid of it. So what is 1 over 99.833? Someone do it in your calculator.
That's a fantastic question.
Come on.
0, 0, 0, 1. No, yeah, calculator. 6, 7.
That?
There's more, but
It's 0
done now. Yeah, it's small.
Okay. So your initial concentration, according to this particular graph, is 0.0100, correct? Okay. Let's look at what the initial concentration we started with in the data that we were given. Doesn't want to do what I want it to do. If you look at your original data set, what was the initial concentration of NO2? Hey, look at that, 0.01. The reason integrated rate laws are helpful are because they always will fit the data that you give them. If we tried to do the same thing with a first order or a zero order version of this, it would not come out correct. So we made our data fit into a second order, and then we can get information from it, one of which is what is K. So rate constants are super useful to have, because then we could calculate rates given specific concentrations. So now that you know what K is from this particular reaction, okay, if I said, what is the rate of the reaction when the concentration of NO2 is 0.005? You would do this. We would use the rate law at that point. You could also use this concentration, absolutely. The problem is you'd have to know what the time is to do it. Okay. Next up, there are practice problems posted on Canvas. Time to download and get to work. Integrated rate laws, that's what you're practicing. It is not due tomorrow, sorry. Yeah, we can do the day.
Do we save each practice class or kind of do we
You can get rid of them, but I would say as long as you know what you're doing to start that practice, which we're going to work on today and tomorrow, or tomorrow. I will open the daily queue for you. Don't understand why we're so scared of the daily queue. Isn't it just to like write? Nice. Pretty sure isn't it just like determine the concentration at a specific time point?
What?
Oh boy.
Yeah, it's a pre-fall thing.
All right, guys. For the daily queue, from what we did yesterday, which thing do you want to look at first, A, B, or C? A. So we need to find two experiments that change predictably for part A. And the other two need to stay the same. So, looking at B and C, in experiments 2 and 3, and in experiments 2 and 3, both B and C stay the same. So I'm going to use experiments 2 and 3 to determine what happens. Question for you. Do we always have to assume that going from here to here... I guess never mind. We'll just go over it. Is there any indication that experiment 2 happened before experiment 3? Heck no. Correct. You should never assume anything about time when it comes to this type of problem. Because there is no time, right? There is no area where you can interpret time. So I'm going to go from experiment 3 to 2. The concentration of A went from 0.2 up to 0.4. So it multiplied by 2. The rate from experiment 3 to 2 went from 2.4 to 9.6. What's the thing? The difference? Is that times 4 or times 3?
Times 4.
So 9.6. So what's the difference as far as like the factor? When it went from here to here, did you multiply by 2? Did you multiply by 4? Did you multiply by 3? Divide them and you get times 4. So it went from 2.4 up to 9.6. So this is times 4. So for A, We need to figure out if it's first, second, zero order, right? So we're going to start, remember, we always start with what the concentration changed. So 2 to the x will equal the change in rate. So A should be second order, because x would equal 2. We did this yesterday. So then the next one, we need to find, which one do we want to analyze next? B or C?
Can we do all of them?
Let's do B. All right. B, in experiment 1 and experiment 4 goes up by 2. I'm always looking for like a factor of 2 or a factor of 3 or a factor of 4. I'm never looking for just going to like from point 2 to point 3. Like that doesn't really have a finite difference. If I look at experiment 1 and experiment 4, do the other two stay the same? Nope. We'll continue tomorrow.
So this isn't due at the end of the
What, this?
We'll continue tomorrow.
Yeah, we'll continue tomorrow with this one. Yeah, I'll finish it up with you tomorrow.
Why did it say?
I mean, you can finish it today if you go back to what we talked about yesterday. Say again?
Why did you say